All right, so today we're going to divide with complex numbers. When you're dividing with complex numbers, you have two types of problems. The first type of problem is that you have only an imaginary number in the denominator. When you have only an imaginary number in the denominator, the way that you're going to simplify this is you're going to multiply by I over I. Now what this does, mathematically, you're multiplying by 1, so you're not changing the original problem. 3 times I is 3i, and 2i times I is 2i squared. But remember, I squared is -1, so you really have 2 times -1 in the denominator, so you end up with 3i over -2. And all this does is get the imaginary part out of the denominator. Another example here, you got 5 plus I over 8i. We don't care about the numerator, we only care about the denominator. The denominator is only imaginary, so we multiply by I over I. Now when we do this, we're going to distribute this I to this, so we're going to get 5i plus I squared over 8i times I, which is 8i squared. Now, I squared is -1, so your denominator becomes -8. Your numerator, you still got your 5i. But I squared is equal to -1, so you end up with -1 plus 5i over -8. Okay? Now, if you have a denominator that is truly a complex number, that is 3 plus 2i, so there's a real part and an imaginary part, multiplying by I does not get rid of the imaginary part of that denominator. Instead, you have to multiply by the conjugate. The conjugate of 3 plus 2i is 3 minus 2i. And just like up here, when we multiplied by 1, down here, you're also going to multiply by 1. So what that means is if you multiply by 3 minus 2i on the bottom, you've got to multiply by 3 minus 2i on the top. Okay? So we're going to distribute, we're going to simplify, and we're going to see what we get. So here you've got 5 times 3 minus 2i. 5 times 3 will give you 15. And 5 times -2i will give you -10i. Okay? It's pretty easy for the numerator. For the denominator, you're going to multiply these 4 terms using the distributive or the FOIL method. 3 times 3 will give you 9. 3 and -2 will give you -6i. Then you'll get +6i, and then you'll get -4i squared. These two terms will cancel out. If the two middle terms do not cancel out, you have done this incorrectly. So then we need to simplify. The top doesn't simplify because you've got 15 minus 10i. And that's a real number, that's an imaginary number, that's all there is to it. But here you have a power of I greater than 2, or greater than 1. So I squared is -1. So what you actually have here is you have -4 times -1, which gives you +4. So in the denominator you have 9 plus 4, which is 13. Okay? Over here to this one, same concept. We have a complex number in the denominator. We're going to multiply by its conjugate, which is 4 plus I, top and bottom, which is the equivalent of multiplying by 1. 5i times 4 plus I is going to give us 20 plus 5i squared. Okay, 20i, almost missed that one. 5i times 4 is 20i. 5i times I, 5i squared. Then the bottom, you're going to end up with 16 plus 4i minus 4i. And then -I times I is -I squared. These two are going to cancel out. And then we need to simplify. So the 20i, we're going to leave it alone. 5i squared, this is -1. So 5 times -1 is -5. Down here, this is -1, right? Because that negative sign gets copied, and I squared is -1, which is the same as +1. So this will give us 16 plus 1, which is 17. Okay? Couple more of these for you folks. So here goes 3 plus 2i over 5 plus I. Same thing. We're going to multiply by the conjugate. Now the important part is, remember, the denominator is the one breaking the rule. So we record by the denominator's conjugate, which will be 5 minus I. And you multiply by that on top and bottom. That is going to give us, so 3 times 5 is 15. 3 times minus I is minus 3I. Make that a little longer. 2I times 5 is 10I. And 2I times negative I is negative 2I squared. Then multiply the bottom. You're going to get 25 plus 5I minus 5I. And then minus I squared. Those should cancel, and they do. So then what do we get? Well, I'm going to start by combining the imaginary numbers here. You got negative 3 and plus 10. It's going to give you plus 7i. Remember, this is negative 1. So negative 2 times negative 1 is plus 2. 15 plus 2 is 17. And then on the bottom, this, we just did it up here. And it gave me negative 1, which was plus 1. So this is going to be plus 1. So 25 plus 1 makes 26. Okay? So that's our final answer for that one. And last but not least, this one here. Same thing. You have a complex number in the bottom. You're going to multiply by the conjugate, which in this case is 3 minus 7i. 3 minus 7i. Top and bottom. And then we're going to come down here and multiply these. This is going to give me 9 plus 21i minus 21i, and then minus 49i squared. Okay. And then up here, 4 times 3 is going to give me 12. That's going to give me minus 28i. That is going to give me minus 9i. And then 3i times 7i. Both are negative, so that's going to give me a positive. And it's going to be 21i squared. Okay. Now I've got to reduce all of this and combine like terms. So here goes. Oops. Make a straight line would help. So on the bottom, those two cancel. This is negative 49 times negative 1, which is plus 49. So I have 9 plus 49, which is 58. On the top, negative 28 and negative 9 are going to add together and give me negative 37i. And then this is 21 times negative 1, which is minus 21. So I have 12 minus 21. Okay? So that is going to give me something like 9. That sounds right. Okay? So 9 minus 37i over 58. 9 minus 37i over 58. And again, the biggest thing that people will do wrong is they'll mess up their exponents, or they'll add and subtract wrong. So this is how you divide with complex numbers. And I'm just going to say this one more time. If you only have an imaginary in the bottom, you multiply by I over I. If you have a complex number in the bottom, that is a real plus an imaginary, you have to multiply by the conjugate of that number. When you do that, the denominator will always become a real number every time. Real, 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 real. No imaginary. It has one term. So, all right, guys, get homework number 10 done. I hope this helps. See you next week.